All right, so now we should be recording. And yeah, so I'm Ferris. I helped start this group with Joe. Dylan is also one of our co-hosts, co-founders. We have a few groups around Utah now. We actually have Python Utah North. Louis Shabib is my father, and he runs that right now out of Logan. They are a small little group of Python developers in Utah as well, but they have moved to online. They have some interesting events coming up. You can find more details here. Salt Lake PyLadies are a group from Salt Lake, and they are part of the PyLadies. I mean, it's kind of self-explanatory. The whole goal of Salt Lake PyLadies is to try to empower everybody to take technology into their hands and use it for betterment, kind of what we're trying to do here at Utah Python as well. So Python at the Point is Python Provo, Girl Develop the SLC, more language agnostic and more workshop oriented, also a great group. Utah Data Engineering Meetup. Joe, do you want to give a spiel about your meetup with UDEM?
Yeah. So we meet once a month, third Wednesday of the month. We obviously talk about data engineering related topics. This month, Wednesday, October 21st, we have somebody from Fastly, company in San Francisco, talking about turning data flows into LookML with dbt. If you do not know what dbt is, it's the hotness in the data world right now. Write select statements and transform your data like a rock star. So that's going to be great.
Dialectical behavioral therapy.
That's
right?
certainly not it, but we could do a meetup on that, I guess, sometime.
Yeah.
Yeah, get DBT would be the one. But anyway.
You see how I showed everybody how to Google stuff, where you just add Python to whatever you're looking for, and it's like, oh, it turns out to be a package. So
Fishtown Analytics is the company behind DBT too.
Yeah.
So if you look up Fishtown Analytics, you can see kind of the marketing business side of the open source tool DBT.
But say if you're in the data space right now, DBT is definitely something you want to get to know. It's been on the scene for a few years, but as of like the last 6 months, it's really gotten a lot of traction. And I think next year is going to be like the year of DBT, like hands down. I'll bet money on it. So
yeah.
So anyway, that's the meetup, and
so that's so that's UDEM. PyData SLC is another meetup. Here's the link. SLC devs, language agnostic. Not sure if they've continued during COVID right now. Here's the websites. If you feel like you want to hack on something open source, I think it's Hacktober, right? So if you want to make an open source PR, our repos could always use some love. We need to update just a couple. It's literally would just be text updates at this point. So those are some fun ones. Yeah, you could get your Hacktober t-shirt. That's always cool. So here's the link to those. Our sponsors are Pythonistas like you. Thank you. Typically, we used to do a $5 optional donation at the door. Right now, there's no pizza, so we're not too worried about that. However, I will point out that we do have other ways to support your meetup group. And I'm not sure, I think some people saw this in the Slack channel, but I'm just going to put this out here because we make a little bit of money on each of these, but usually it's at cost, and it's, yeah. But another cool way that you could totally support our meetup, this neck gaiter that we just got up. So just in time for fall, if you are looking for our logo on a neck gaiter or a face mask, we have you covered. So thank you, Pythonistas like you. And yeah, we can keep doing awesome things as a result of sponsors like you. Xmission has been a longtime sponsor of the meetup. They sponsored pretty much all of our pizzas for like 2 years, more than 2 years now, up until COVID. But they are still in touch, and yeah, they've been a long time sponsor. University of Utah has sponsored our venue. Hopefully they will again. I can now say that we've been venue sponsored by the same venue sponsor as the vice presidential debate. So there we go. They're like high accolades, not really, but whatever. Tech Systems has been a long time sponsor. They are sponsoring our meetup prize tonight. And let me go, I can't find the exact specimen, but I will show you something similar. But it's basically, it's called a Halloween. I'm going to show something different than a Halloween because we're also giving one of these away. Sorry, I'm off camera. I know.
Harris, is it this one? Is it the Halloween wing?
Yes, thank you, Dylan. Yes.
Yes. It's yours that I happen to have.
I know. Is that the golden one? It's not the golden one, is it?
I don't think so.
Okay, so Adafruit gave us a special edition one for this meetup group, and darn it if I can't find it right now, but basically it's almost exactly like what Dylan's holding, but it has a slightly different print on the PCB. So yeah, but we'll be giving away one of those. We'll also be giving away a Circuit Playground Express, and I think I have a spare t-shirt we'll be giving out, or I think I'll just include those with the prizes actually. So yeah, so we'll be doing a raffle at the end of this, and that's thanks to Tech Systems. How to sponsor? We're always looking for sponsors. If you want to do that, it's usually as easy as like, I'll send you like a code that Adafruit gives us for being a nonprofit, and you can buy a few things, and we'll just write it down in our open accounting right here. So SLCPython/money. We are tax deductible, so I can give you more details on that of our tax IDs and all that fun stuff. What else? Okay, so continuing with our agenda. So this is the part where, okay, we did school. So we're going to do a non-coding related thing. So if you're new, feel free in the participants, and you would like to participate. So if you're new to our meetup group, I gotta hit this button here. Okay, excellent. If you're new to the meetup group, you should be able to click, I think for you, it says participants, and then you can raise your hand, and or it's in one of those triple dot menu items. I don't know where it is because despite hosting many Zoom meetups now, I still don't know where everything is on Zoom. So feel free to raise your hand on there. I don't think I can raise mine. Can I? Nope. Hosts can't raise their hand apparently. But if you're new to the meetup and you'd like to introduce yourself, go ahead and raise your hand. You can also hit the raise hand emoji, but I might not catch it. That's a reaction. Oh, wait. I'm catching a couple. So, Wang, am I pronouncing your name right?
Oh, yeah. Just a second. Okay, yeah.
No, go ahead and introduce yourself. Tell us your name and occupation right now, and what's your favorite Halloween costume, maybe that you've seen or worn.
My name is O1, and you pronounce it right. And I'm a MSIS graduate from the University of Utah. I'm interested in data analytics. That's why I'm here today. My occupation right now, I work at Young Living Essential Oils, and I do regulatory affairs. It has nothing to do with data and analytics. It's more like legal and regulations. My favorite Halloween costume. Last year, I think I see a Ghostbuster. I think it looks pretty cool, but it's not awesome. Mine. Yeah,
that's awesome.
Yeah, I was driving like a 80s, like those fake hairs, but I saw the Ghostbuster is pretty cool.
Yeah. Do they have like a vacuum cleaner on their back and everything?
They do, pretty professional. Yeah.
That's awesome.
Yeah. All right. So what else should I say?
So
name,
yeah, that's it. Oh. No, and then we're just doing quick intros. So I see that E. Miller has raised his hand. Okay. Yeah, would you like to introduce yourself, Mr. E. Miller?
Sure, I can. So it's Evan Miller. I'm currently working as a data scientist at Sorensen Communications. My favorite Halloween costume, I did a group costume a number of years ago where we were the Oompa Loompas, the old style Oompa Loompas, not the timber and Oompa Loompas.
That's perfect. Like the old style is like the only ones that you want to do, because the new ones, you just have to be the same person and somehow like Photoshop a picture of yourself over and over, right? Because
Yeah.
that's what the new one was.
Yeah.
Like instead of hiring a bunch of actors, but group
Yeah.
costumes
No.
are great.
Though orange skin and green hair was also pretty fun. So.
Sweet. All right. Is there anybody else who'd like to introduce themselves? Feel free to raise your hand or react on Zoom. I don't see the reacts as easily, but I can hopefully bounce back and forth on the gallery view. Anyone else? Going once? Going twice? All right, so let's move on. I am still screen sharing. Excellent. So now's the part of our meetup where we like to talk about who's hiring and who's looking. So we'll take a quick look at the job market. Couple links that I've been keeping up since April are that PyCon went completely online. There is a link right here. That job board has been fairly updated. They haven't had an update for a few weeks now, but it's still a good solid start to see where things are. Python Jobs HQ is an ongoing real-time, like anybody can sign up if you have some Python acumen. And Tech Systems, reach out to Kate Conroe. She isn't in the Slack. And you know, I'm not endorsing Tech Systems straight up for all of their, well, I am endorsing them because they hired me at one point, but not lately. But I am saying that, you know, sometimes going with the recruiter works. And Kate is a good one. Like personally, I know her. So Invitae is where I work. Feel free to message me if you're interested in genomics. They're looking for more senior dev positions right now, but that's all remote. Galileo.com. Did somebody add this just now? Ramon? Are you on Zoom right now, whoever added it? See, that's the nice thing about it. Okay, this might be from last time. Sometimes I do that. Haha. Recursion. Who added recursion? Who would like to talk about recursion? Hi,
I
Isla.
added recursion.
Long time no see.
Yeah, it's been a while. Recursion is hiring for multiple roles, everything from scientific roles to data science to lab automation to, oh yeah, we're looking for a senior cloud infrastructure engineer. That would be on my team. So we're just looking for good people with a passion for biotech and learning, and yeah, check out the jobs page.
Awesome. Thanks, Isla. I was actually talking to Eric, who I used to work with, and now he's at Recursion. So
Eric
Hurst. Yes.
Yes. Yeah. He's doing very well there.
Yeah. Awesome. Awesome. All right. If anybody else, oh look, somebody's adding another one. Progression. I think this was pasted in the Slack channel, and now we get to hear about it synchronously.
Yeah, well, I'll speak on their behalf because I was talking with Kendall Brennan over there today about it. So they're hiring for a couple positions. Geez, what is he looking for here? My Slack never opens up. They're looking for a senior data analyst and a data engineer. So if you're one of those and want a job, go there. The other one would be, well, I'll let you keep up with the speed of typing. Actify. So they are looking for senior engineers, data engineers, that sort of thing. So Overstock's hiring too. There's a lot of places hiring.
Oh
right now.
yeah, I heard. Yeah, I heard Overstock is hiring. All right. Anybody else? Now's your chance. If you want, you can raise your hand in the chat, or you can send a reaction, or you can just cut in right now and say that, hey, I know so-and-so's hiring. Going once? Going twice? All right. Let's move on then. So who's looking? I cross-filling out over here. So now's your chance to, do you want to tell people where you're at now, where you landed, or?
Yeah.
Yeah.
Yeah. So I got a job. I'm working at an energy tech company that has an IoT solution that gathers information about how electricity is being used, and then we gather the data and do analytics and machine learning on it to try to make buildings run smarter. So smart buildings. And I'm real excited to be working there.
Awesome. Congrats, Dylan.
Hey, what's the name of the company, by the way?
Oh yeah, it's a Verdigris.
Verdigris. Okay.
Yeah. Which I learned is the green that comes on copper when it oxidizes. That green is called verdigris.
That's today I learned. That's awesome.
Learn something every day.
Let's see, who else is who's looking? And now's your chance. Raise your hand, and then you can introduce yourself. Ross, I see your hand. Take it away.
Yep, I'm still looking for a job. I'm a junior Python developer, and right now I've been focusing on jobs entailing either QA or automation or both. That's what I've been kind of working on, those sort of technologies. So if you know of anything, let me know. It'd be appreciated.
Hit me up, Ross. I think we have an SDET thing. But
Oh, sweet. That'd be awesome.
yeah, I'll send you a link on our greenhouse. Might not be a perfect fit, but hit me up. I think we have something.
I'd still check it out anyway.
Cool. Anybody else who's looking? Oh, anybody? You can raise your hand, give a reaction. Oh, Drew Gillis? Oh, I think you have a physical mute button on your.
He's good now. He's good.
Mike, can you hear
Oh
me?
yeah, now I can hear you. Now you're coming through. Okay.
So I'm currently doing like data engineer type stuff with Python stuff, but I've been trying to break into data science. So just kind of putting feelers out, not super actively looking right now, but will be in a few months. So.
Sweet. I put that you're putting feelers out. Awesome. Anybody else who would like to let us know about yourself, market yourself, or if you're looking for a dev role? Going once, going twice.
This is good. It's like the good old days of
Yeah, this is.
unemployment.
I like this signal. Yeah, this was a running joke that our group pretty much. It's usually more people hiring than looking. Like probably closer to 9 out of 10, maybe even 19 out of 20 of our meetups. So I like this ratio. I miss this ratio.
Yeah,
Excellent.
the only time
Thanks,
I think it kind of hit the wall was what, April or May.
It hit it, but it wasn't like hitting the wall so much as just Utah had like a weird month. But
Yeah. Job
yeah.
market here is doing really good. I mean, what Utah's unemployment rate, I think, was like 4.7% now.
Yeah, it's one of the best ones in the nation, so that's pretty good news. Yay, good news. All right, well, let's talk. Speaking of good news, let's talk community news. Thanks for the segue, Joe. So we got, well, I've had this on for a while. This isn't really news anymore, but here's the PyCon 2020. You don't got to pay for a ticket, but these are excellent talks. Python release candidate for 3.9 has been released, and I was thinking usually I do like a simple Python demo before the main talk. So we could either do one on Pandas, but I'm not sure if it's fully installed on this machine. I think it is, so we could do that, or we could do a quick talk on how to like run 3.9 on a Docker file if you wanted to do something crazy. So we might play with that. If either way, even if we don't get to either of those things, here's some links. So if you want to play with 3.9, something new that comes with 3.9 is the union of dictionary specifications. So this is kind of interesting that if a key appears in both operands, the one from the right-hand operation wins. So I can't wait for junior developers to abuse the crap out of this. So Dylan caught my joke.
Yeah.
But yeah, so this is added. It's something fun to have to play with. Yeah. Let's see, where was I? Oh, this guy. Okay. Utah Python logo. We have a new logo now. So if you want to support Utah Python, this is a PSF approved Python logo, pretty much available to everybody. And I think we got to, oh, add this as a to-do, Dylan. Oh, nice. Yeah, I was going to show off ours too. So Dylan is showing a face mask right now of our logo. It's pretty sweet. Yeah, nice. And then I'm going to show this one. It's still in the packaging, and this is one that we'll be sending along with. Yeah. So I'm not going to open this, obviously, but we have this one for a face mask, and then this is our neck gaiter. And I really want to open it up, but obviously I shouldn't. And I can't wait to see. Somebody should send a picture if they get this. But yeah, keeps your neck warm and keeps your mouth vapor to yourself. Okay. All right, let's move right along. Data heretics. Joe, did you want to talk more about this, or?
Yeah, so got looped into giving a live discussion on all things data heresy. So controversial topics in data. We'll be talking about those tomorrow night, 8 p.m. Mountain Time. It's a global group. I think there'll be around 600 people on there. So it's like a mini conference, but yeah, if you want to hear me totally embarrass myself and show up to that, it'll be a lot of fun.
That's a great way to spend a day. Watch
Yeah.
your friends embarrass themselves. So.
Yep. Foot in mouth.
No, I'm sure you're getting kick butt at it.
No, we do great, man. It's good. It's a lot of fun.
Sweet. Let me find this example. I think I was gonna. Maybe I should do this example. Or Dylan, what do you think? Do you think you're up for the other thing that I was slacking you, or you're just not feeling?
I think I could do it.
Yeah? Okay,
Yeah.
so in a demonstration of Dylan's amazing skills of live coding, because he has Pandas installed for sure, Dylan's going to give us a quick overview of Pandas and what Pandas is. And this is more oriented for people who haven't really dabbled in too much Python, but maybe you have it installed, or maybe you got the Anaconda library, or maybe you installed Visual Studio Code. By the way, while Dylan's loading things up, so I'll have you share, and then I'll walk you through a tutorial. How about that?
Okay. Yeah, let me just.
No worries. I put Dylan on the spot here. So while Dylan's doing that, let me tell you guys a little bit about Pandas is a data analysis tool. It's really powerful. It's great for grabbing any kinds of data sources from an SQL database to a flat file of CSVs. And then it lets you manipulate that data like a Python object with all kinds of nice speedups under the hood. If you're looking to learn more about this stuff, by the way, as we're going through, I'll be sure to paste links in both the Slack and the Etherpad. And if you want to just talk offline, we have a Learn Python channel. Definitely paste a question in there. Any one of us will hop in and help out.
Yep.
Cool.
So one way to get Python installed on your computer, and one way that let me take a step back. The little tutorial that we're going to talk about and let anybody ask questions. Essentially, you have expert Pythonistas here that you can ask questions of, but websites like Real Python provide really good learning tools for Python and for data science. We're going through this one. Pandas is a tool within Python that does table manipulation. So if you have a table of data where you have rows and columns, it's very good. It does a few other things, but it's very good at that data structure and providing lots of useful tools around that. So if you're doing any sort of data science, the Pandas data frames, or the concept of a data frame in general, is a really good concept to have, to be familiar with. So in this tutorial here, they recommend installing the Python Anaconda distribution. I have it installed over here, and I have actually the graphical interface. So this makes it a lot easier. You don't even have to have a familiarity with the command line, though you can also do these things from the command line, but you can come in and launch either, in this case, we're going to run Jupyter Notebooks or Jupyter Lab. It's a way to run Python. So when I clicked on that button, it starts up the Python package called Jupyter Lab, and that gives me this editor. That allows me to interact with Python. And so here I create a new notebook, and the notebook is essentially structured into individual chunks of code that you can execute. So here is code, hello world, and then I can execute that code. If I want to do any sort of manipulations, this does it one at a time and gives me the output. So in some parts of data science, you have this exploration, and that's where a notebook is really useful for doing explorations into the code itself. And then you take those explorations and turn them into scripts and into software that can then run. But this is a good prototyping exploration framework in order to run Python. Ferris, are you watching for any questions?
Yeah, I got your back. I see one in the chat, and
Okay.
it's just Joe saying yikes in response to somebody having a meltdown with the VS Code on their machine. So, yeah. And then some background. I sent this link over to Dylan just as a, hey, I thought this was a really well put together tutorial. So I actually got in touch with the real Python folks, so expect some news maybe related to that org soon. But yeah, if you're looking for Python tutorials, this is a great link. So I'll also link this same tutorial that Dylan's trying out in our Slack. So what Dylan's doing right now is he's setting up some imports, right? You have other people's libraries that we're relying on. Specifically, we're going to use pandas, and that's the library we've been talking about, and matplotlib, the pylab plot. So basically, that's a shortcut on both of those so that we can make some pretty images based on data. Next thing on line 5, what you can see going on there is the URL. We're going to set that aside. And notice on line 6, the really cool thing that Dylan did is he did not have to call, hey, go download the CSV. He didn't have to import requests. All of that is handled under the hood. So if you pass in a URL for a CSV, you're going to get back a data frame. df becomes that variable name, and now we have a data frame. You want to do a typed data frame just for fun to show hey, this is how you can do a type.
Yep. One of the really nice things that I appreciate about Python is there's a constant effort to essentially abstract away things that are repeatable and bring up the logic of your business, of your exploration, of your code. You try to bring the logic all into one place so it's very concise and clean and abstracts away all of the complexity. So for this example, this read CSV, reading a CSV has a lot of complexity. If I type help and I look at this, there are a lot of parameters, and each of those parameters has crazy spread of space in order to just read in the CSV. But what this library has allowed me to do, and other Python open source libraries allow and make it really easy, is to make my code look very clean by abstracting these pieces that are common away and bringing up to the surface the pieces that are actually relevant to what I'm working on.
And then a data frame is actually a really good example of that, because instead of doing, an array by an array in Python or trying to do any kind of representation that you've done homegrown, Python data frames use a lot of extra tooling under the belt. They'll talk directly to some sped up libraries to these are solved problems, right? You're not going to want to reinvent the wheel when it comes to making any kind of table, right, on a computer. We've been doing that for years. So yeah, and here's a good example of that table. So as we're looking at that table, that data frame, here's a call that we made, data frame head. And as you can see, we got the first few rows of that.
Yep. Something else I'll note that I do a lot of is I'll actually add a .t. And so what's happening here in Python is it's calling this method on the data frame, returning another data frame, which you can see here, that's the top 5 rows. And then this is actually transposing it. And so when my data frames get really large, I'll do this. And now I just have, instead of columns that are, my columns are actually rows. And so when I want to look at data, I'll use this, and then I can see more columns at once, kind of the values that go into it. Combining the notebook and Pandas data frames together, they give you these really nice table visualizations of your data, kind of like an Excel view of the data, which is really helpful.
All right. And I think in this tutorial, the next part will be I'll plot it. And I think this is covering the inline stuff. Have you written your own magic method?
No longer required.
Yeah. Oh, that's a good point. Yeah. Okay. Good.
So these pieces right here were originally you had to do these when using a notebook, but now they're done for you, so they're not necessary. You can still
we're
add
getting
them.
one question. The T, it stands for transpose, capital T. Sorry, we've got a question in Zoom and I missed it.
That's fine.
The capital T is for transpose. And yes, it looks like Miller answered. So.
Are people familiar with what transpose does?
Yeah, so here's it untransposed. We have the columns along the top and our rows going down, and transposing flips those, transposes it so that your columns become rows and your rows become columns. Usually not very useful, but it's very useful when I do exploration of this sort.
There's another place I've seen this used. Some organizations, if they're trying to speedily do some data entry, they'll actually give you a spreadsheet that kind of looks like this, where you'll see each row should be a column. So that would be one of the first operations you do if you were to, say, import that CSV. A case in point, if we want to talk community news, in the UK, you might have read about that debacle where Excel was being overused to store COVID cases. That was part of their pipeline, I discovered when I was reading into this some more. But basically, yeah, they had an Excel spreadsheet with a ton of columns, but they ran out of columns. And that caused some issues. So data. And then let's, so the plot
so one of the
here.
helpers that Pandas provides is this wrapper around matplotlib, which is a plotting library. And if I call my dataframe.plot and I specify the columns that I want to plot, it will plot those as lines for each of mine. So you can see now here, we have our median value, we have our 75th percentile and our 25th percentile. So that we can start to visualize it and see, not just in a table form, but actually what does our data look like. I did do one thing here. Matplotlib has a separation of styles for the plots, and this was just to make the plot a little bigger. But there's a bunch of different parameters that you can configure for Matplotlib.
Awesome. And yeah, that's some basic plotting with Matplotlib and Pandas. I think the rest of the tutorial will just cover under the hood. And
yeah, it explains a little bit about how it's functioning. So Matplotlib has a plot function. So if I wanted to do this directly, I could do something like my data frame, and it uses the index. Oh, it's using the rank. Is it capital as X?
Yeah, capital R. Yeah.
And
yeah, you got it.
Median. So in this case, I'm doing the exact same. I think I have to do unexpected value X.
Is it supposed to be plot top? Yeah, there we go. What? Huh.
Not exactly sure. I have a suspicion, but essentially I am taking my X value and my Y value and it's plotting it up. So it's the same as this line here.
All right. Do you think we have time to do that correlation example at the bottom?
Probably. So Matplotlib has a couple other nice things. You can do bar charts. You can do a lot of the typical like BI tool manipulations. So like analytic tool manipulations, scatter plots, bar plots, pie charts. Was there, wait, where are you seeing this, Ferris?
You kind of skipped past it, but it was so that the data set that we're looking at is the job numbers, right? So employment rates and what have you. So from 2018, I think you could do oh, okay, we can do a kind. Yeah, there we go. And we can do that. And we can do a kind equals scatter for, so df.plot, paste it in our Slack actually. And then meetup Slack.
Another library that's useful to be familiar with is Seaborn. It's another wrapper around Matplotlib.
Have you played with Altair yet?
I've played with it a little bit. The one that I'm most excited about right now that I'm using in my job is Plotly. I'm actually really liking Plotly's interface and their like the interactivity. One of the drawbacks of Matplotlib is the interactivity relies on a backend that does the interactivity. So in the command line, you can typically get a visualization that comes up and you can interact with it. But to do it in a notebook, you have to add something like Matplot D3 or some other tool. And it's just not as polished as some of the other like Voltaire or Plotly or Bokeh that are other plotting libraries. Don't have as big of a community around them as Matplotlib does, but they really have a much cleaner plotting interface and cleaner for embedding into web interfaces.
Excellent. Excellent. And I think let's move on actually, and we'll paste some of these links in. Audie, are you pretty much ready to give your spiel? And then if there are other questions, feel free to drop them in either the Zoom or the Slack.
Yeah, drop them in the Slack. I can answer any questions regarding this, Matplotlib, pandas.
Cool. Thanks, Dylan. Audie, are you ready to go?
Yep.
Awesome. I'm going to hand it all over to you then. I will give you a quick intro, actually. So Audie is a senior data scientist at Extra Space Storage, and he's going to be giving us a talk about optimization models in decision support systems. And sounds like it's going to be a pretty in-depth talk, so I'm looking forward to it, Audie. Yeah, take it ahead. Take it away.
I was just about to say it's a pretty high-level talk. That's how I put it together, but please feel free to interrupt at any point and ask for more detailed questions. And
oh, no worries. Pythonistas are smart people, so we know when we don't know stuff. So we'll ask, don't worry. And then, yeah, so feel free to ask questions in the Zoom chat, and we'll look out for them.
Sure. Okay. Can I see my screen yet? Or let's see.
Here we go. Yeah, it's starting.
Okay. Actually, cool. The talk is around optimization models and decision support systems. Just give a quick background about the data science team here at Extra Space. My manager formed the team almost 10 years ago now. Like, he has an OR background. He was primarily hired to to build a revenue management system, and we have a couple of other.
So for those who don't know, what's OR?
OR is operations research. It's a field of study that I'd say kind of took off right about when World War II happened. So they were trying to solve these big logistics problems about how to move ships or how to optimize your airplane sorties and things like that. So that kind of gave birth to these optimization models and something related to it, discrete event simulation models. So it's a field of study that began there, and it's primarily taught in management schools and some engineering schools. So I went to grad school for industrial engineering, specializing in operations research, and that's where I picked these skills. So anyways, yeah, so since we were talking about Halloween pictures, this is something I found from, I think, last year, year before. Our team did a It costume with one Georgie, so which is kind of fun. I'm kind of proud that we actually pulled it off, like convinced everyone to do it. So just want to show it there. A little background about extra space storage. So it's a self-storage REIT established in 1977. We manage about 1,900 properties. Some of them we own, some of them are third-party stores that we manage. We service about a little over 1 million customers every year. We are an S&P 500 listed company, and we are the largest company by market cap in Utah. People are usually surprised by it. Even I am surprised by the money in the self-storage business, but it's a pretty good business and a good company to work for.
One note I just got on Zoom, Audie, just so you know, it seems that you're sharing your presenter mode. I don't think it's a big deal, but we are recording this, so just if you wanted to show your
notes, but I'm going to see if I can switch to the other screen.
Yeah, that's probably what it, yeah. Sorry to break up your flow there.
No, you're fine.
The Halloween costumes look adorable, by the way.
Thanks. Can you see my other screen now, or is it
yeah,
still...
this looks amazing. This is perfect.
Okay, got it, cool. Okay, so just an agenda. We are going to go over some of the most popularly used optimization models, which are linear, integer, and nonlinear. And then I'll give you a flavor of how we use them at Extra Space. So optimization models, just to set it up, let's say starting with an icebreaker question, if you're stuck in an island, what are the top 3 or 4 things that you take given 10 different things? So let's say you're provided with a knife, a flashlight, a sunblock, a fishing net, a hammock, etc. So the thing is, you're given a set of options that you can choose from, and you're taking it in a backpack or a knapsack. And how do you optimize? What are the right things to pick among the options that is provided to you? And how do you go about choosing them? Can be modeled as a decision problem, classically called as the knapsack model. So you can build it define it as this way: maximize value of items in your knapsack, subject to weight of items in knapsack less than the maximum weight your knapsack can take on. So this is a classical computer science problem. Some of the computer science folks might be familiar with this. This is a classical optimization model as well. So the maximize function, it's called the objective function. That is what you're trying to either, in this case, maximize. In other examples, you will try to minimize a certain function. And subject to a certain threshold, a constraint. So an optimization model, the ones that we are going to review, all of them would have an objective function and a constraint. With that, let's start with the simpler one, a linear optimization model. We'll go a little in depth here and build a model out. So let's take a manufacturing problem. You are a furniture manufacturing shop, and you make chairs and tables. Let's say a chair sells for $45 and a table sells for $80. And these are the raw materials or the resources needed for the chair and the table. About 5 board feet for mahogany and 10 man hours. For the table, it's 10 board feet mahogany and 15 man hours. So, but the plant also has a resource constraint. Like usually we don't have infinite supply of man hours or mahogany. So the plant has 400 board feet of mahogany and 450 man hours available per week. So given this setup, how many chairs and how many tables do you want to manufacture so you can maximize your revenue? That's the optimization problem. So how we would formulate it in the way that I just showed for the knapsack problem would be to, define a variable for the decision that you want to make. So these are called as the decision variables. So x1 equal to number of chairs you want to produce, x2 equal to number of tables you want to produce. And this is the optimization model. So here, your objective function is $45 times number of chairs produced plus $80 times number of tables produced. So this is what you want to maximize. This is the revenue function. Subject to, you have some constraints on the wood as well as man hours. So you have 400 board feet of mahogany available for this. So we saw that the chair needs 5 board feet, so 5 times x1, plus the table needs, sorry, I made a mistake, 20 board feet, so it's 20 times x2, less than equal to the total availability, which is 400. Similarly, for the man hours constraint, you have 10 times x1, that's the number of hours needed to make a chair, and 15 times x2, that is the number of hours required to make the table, less than equal to 450. In almost all the linear programming problems, we want to also ensure that x1 and x2 has to be greater than or equal to 0. So you're never going to produce negative 1 or 2 chairs or tables. You're either going to produce or not. So make sure that these decision variables are always 0 or greater than that. Any questions with the problem formulation?
I will say, if you played Fallout or any of these Bethesda games, they play with this problem a lot on the player. You have to optimize the value of the items in your virtual backpack versus, the weight of those items. So,
yeah,
this is excellent.
So this is we're just using 2 variables here. So we can kind of graphically look at how the solution space would look for this problem formulation. So we'll go with that. So first, starting off, adding the mahogany constraint to this 2-dimensional space. The x-axis is number of chairs produced and y-axis is number of tables produced. So the first constraint is on the limit on the mahogany wood available. So that's 5x1 plus 20x2 less than or equal to 400. And you can see where x1 lies on the x-axis here. If you make x2 0, that would give you x1 is equal to 400 by 5, that's 80. And if you do the same for x2, where you make x1 0, you get x2 equal to 400. So you get those points and then you draw a line connecting those. Similarly, you can do the same thing for the man hours constraint. And that's the second constraint you have. You add to this plane. Now, this region that is encapsulated between these 2 lines, that forms the what is called the feasible region of our problem. So our solution can only be within this region here. So to evaluate what the optimal solution is, I'm going to go step by step on what is called as a simplex algorithm, which evaluates the objective function that we have at each of the vertices that are in this plane. So we have a 0, 0 vertex here. There's a 0, 45, 0, 20, and 24, 14. So these are the different vertices, and the simplex algorithm takes our objective function and estimates what the value is at each of these vertex points. So the objective function, if you remember, is 45x1, $45 times number of chairs produced plus 80 times number of tables produced. At 0, 0, if both x1 and x2 are 0, is 0. Let's say if we evaluate it at 0, 20, it's 1600. At 45, 0, it's 2025. But at this point here, it's 24, 14, it's 2200. So that is the maximum revenue that we can, looking at all these values that were generated, you can see this is where the optimal solution of the model lies. Even for larger linear programming problems, simplex model is pretty efficient, even bigger dimensions. So you would be imagining, instead of a line passing through these vertices, we will be looking at a hyperplane being evaluated at the different vertices. So this is an example of a linear programming model.
Can I clarify that really quick, Adi? So are you saying, just in layman's terms, supposing instead of just an XY axis of number of chairs, we could add one more axis? It's not just tables. We're also looking at, we also have this buffet that takes a lot of wood, but it's worth quite a lot. So we also want to add, okay. And that's what you mean by a hyperplane, is instead of having a point, as soon as you have another set of axes, the math kind of gets weird. So you're going to have to lay, okay, interesting.
Yep.
Thank you.
Cool. Yep. So this is a maximization problem, right? So you have a bounded feasible region, and you can see that the optimal solution is at kind of at the edge of that feasible region, furthest available from this 0, 0 point. I'm not going to go too much into detail in this, but this is an inverse problem where we are trying to minimize. It's a minimization objective, and the constraint here, if you compare to the constraint in the previous slide, here the constraints were we had a threshold that we can hit, but we can't go beyond. Here we have a lower threshold, a lower bound on all these different constraints. So you form a feasible region that is kind of unbounded, but since it's a minimization problem, you're trying to kind of go inward, and the feasible or the optimal solution here for this problem is here, 4.4, 2.2. So it's kind of the inverse of a maximization problem. And sometimes you will see that, okay, in this problem, we are trying to meet these constraints. And this third constraint here is what is the orange line one. The thing is, we think for this problem that a constraint is useful for us in defining the solution space. But if you look at it, it's nowhere near the feasible region. This is a redundant constraint, and we can remove those from the model design. So just something to highlight. So any other questions about the linear optimization model?
I'm not seeing any in the chat, so.
Okay, cool. I'll go over integer optimization. We'll have an Excel simple demo based on the knapsack problem that we just spoke about. Let me just share my screen again. So in the problems that we just looked at, the x1 and x2 were the only necessary condition for them was they had to be greater than or equal to 0. They can be any value greater than 0. But there are times where we would want those values to take integer values. Actually, the first example that I showed, we were producing whole chairs, right? Like we were not producing 3.5 chairs or 4.5 tables. These are that naturally the problem gave out integer values, but it is not always the case where you will generate integer values out of a linear optimization problem. So we have to ensure that the model captures that requirement. There are three kinds of integer optimization models. One is you just want any integer greater than 0. There are other cases where you will have, if you have a couple of decision variables, one of them need to be integers, the other one can be linear. And the third one, which we're going to talk about here, you want your variables to take only either a 0 or 1 value, a binary value, so binary decision value. So going back to that knapsack setup, we have 10 items that we can consider, and these are the different items, these are the different weights. And this is an arbitrary value that I assign to all of these items that I felt what is more important for me. So here, this is the objective. So this is the decision variable here. And I want all of these to be 1 or zeros. So I think I'll just make them all zeros for now. And this is the mathematical equivalent of this model here. So you want to maximize summation of I equal to 1 plus 1 to 10, value of each item times if that item is present or not. Subject to the constraint, summation of weight I times xi less than equal to arbitrarily picking 15 pounds here. So we use Excel quite a bit in modeling toy problems before we put them into production. We use it a lot to cross-check some of it. There are a lot of open source solvers available to solve an optimization problem. Our experience has shown us that not all of them work the way we think they work. And so building a model in Excel and then translating it to one of the open source packages and verifying how the optimal results look like is always a good practice to do. So Excel comes with a solver, native solver. Before I go into this, a couple of things. So I've defined the objective value in this cell here, hit 17, which is basically a sum product of all the value cells times if it's included or not. Similarly, total weight, I don't know, sum product of the weight values times the x's. And I was playing with this, I put 5 pounds as the upper threshold. So after defining it this way, so you go to the solver interface. Main thing you want to first capture is the objective function, which is in the cell hit 17. You want to maximize the value that you're taking. And by changing the variable cells, relation variables, which are in H5 to H14. Subject to the constraints in here on H9. And then you also want to ensure that these are binary, these values can only take 0 or 1 values. There are multiple methods. For a problem this size, this small, simplex would do okay. But if the problem size grows, we probably have to go to evolutionary to solve this. So we solved this and it got us it'll let us know if it got it's an optimal solution or not. All constraints are satisfied. So the objective value, this utility value that I was trying to maximize, is 41. And these are the items that were included: the knife, box of matches, bug spray, sunblock, flashlight, survival guide.
Is this how you put together your camping list now, Adi?
Yeah.
This is awesome. I didn't even know this was a feature in Excel.
You know what? I was actually surprised by, like, this is not as popular as I thought it was. So good to hear that. Yeah, something.
Oh, Solver was a godsend. I think when I was using a lot of Excel in the 2000s, like that was used it a lot. It was so nice.
So yeah, this is a free version. It has some restrictions though. It has, I think, 200 variables is the max you can do. You can upgrade to the Solver, the company. It's a, I forgot the name of the company. It's a, anyway, so you can, it's not owned by Microsoft. That's all I want to say. So it's a third-party company. You can work with them to make it, get the professional version. I think up to 10,000 variables, if I remember right. They also have an SDK. So if you want to, I think Python supported SDK, so you can model it that way as well. But we don't use that as much. So is there a question? Or?
I think Bono was answering your question about frontline solvers. Is that the company?
Frontline solvers. Okay, cool. Yeah.
Yeah.
So now
I have a question. Is this an add-on for Excel?
It is an add-on for yeah. Like it's a default add-on though. So you can go into, if I remember right, options, and then go
Data
into
analysis tool pack, I think, isn't it?
Yep.
This is like one of the most underrated things you could possibly use. I think every data scientist, even though if you don't like Excel, you should learn to like this thing. It's awesome.
Yep.
Analysis tool pack. Okay, thank you.
Yeah.
Excel's great.
That's what's up.
So yeah. So when we build these models, sometimes we want to kind of understand how the answers would look like if you change the parameters, right? So here, if I want to make it up, okay, let me make the total weight 8. So this added a few more things, right? So it went from 41 to 47, total weight went to 6.5. So if you work in any business capacity and you have to make decisions based on budgets and costs, I think this gives you a nice way to see what the different scenarios would look like based on your cost constraints and so on. Okay, I'll go back to my slide deck. Just taking 1 second here, sorry.
And we're seeing the presentation notes again, just so you know. It wouldn't be Microsoft without some bugs, you know.
Okay. Can you guys
Great.
see?
That's looking great, yeah.
Okay, cool. So we saw linear optimization problem, a nonlinear integer optimization problem. Now let's look at some nonlinear optimization models. So linear model, going back to the objective function we are looking at, 45x1 plus 80x2. If you were to play with these variables, right, and kind of incrementally change the numbers, let's say you keep the chairs as 1 and increase the production of tables, you get a simple linear function. There are no square function or anything like that. So it's a pretty simple linear function. Similarly, if you were to change the values in increments of 2, like it's the same thing. So these models they have this nice property, and the simplex uses that to find the optimal solutions much faster than in other kinds of formulations, including integer. So, but let's say if this is your new optimization objective function you have, price times demand. The thing is, when you change price, demand kind of changes with that, depending on, for most of what is in the market, right? So let's say you start with $100, demand is 50, you come down to 70, your demand has gone up by 80. That's the basic economic assumption. So, but the product of these two lines is kind of a quadratic function. So when you have functions like this, it becomes harder to define that feasible region the way we define with linear models. And it makes it harder to find the optimal solutions there. So when we deal with nonlinear models, we need to consider whether these functions that we are working with are convex or not. So I'll just quickly talk about what convex means. So what convex sets are. If a set of points is within, let me just read this actually. A set of points is convex if the set contains the entire line segment joining any two of its points. So for example, let's take these solution spaces. The first one here, take a couple of points A and B anywhere within the solution space, you should be able to draw a straight line. If it is here and here, you can draw a straight line. So it's the line is fully encapsulated within the solution space. Similarly, for the triangle here, A and B, you have a line that's joining these 2 points. C and D, it's still within the solution space. If you go to the third one here, A and B is definitely within the solution space, but if you take C and D, it goes out of the solution space. So the first two on the top are considered convex sets. This one is not. If you're done some optimization for machine learning models, you might have seen these curves, and if you have used gradient descent, maybe this is something you can easily relate it to. So looking at these two functions here, right? The function on the left is if you define the solution space within this, it's a convex function because you can draw this line A and B connecting 2 points within the space, and it'll be within that space. But here, obviously, this is something like some modified sinusoidal curve, and it's going out of the solution space. So this is not convex. The problem, the reason convexity helps in finding the optimal solution is there are no, there's only one trough here. So there's only one global minimum. There's only one local minimum or one global minimum that the optimization algorithms can easily get to. But here, the global minimum is here, but there's also a local minimum here. So depending on the algorithms that you use, if you were to start your search somewhere here, you could get stuck here and your algorithms might suffer, may not recognize that there is a better solution available here. So when we work with nonlinear models, it's advisable, or if we can restrict it to a convex version of it, that would guarantee a global optimal solution compared to a non-convex model. Even a non-convex function, right? Like if you were to take only a portion of the function, and because of the constraints that you have, then it will work fine. Like here, if you're only looking at this space here, that's a convex space. So when we look at nonlinear models, validate if the functions that you're looking at, both at the objective level as well as the constraint level, if they are all convex or not. Any questions? Okay.
So yeah, I didn't see any in the chat. Yeah, go ahead.
Cool. Okay. So these are the three main umbrellas of optimization problems, I would say, but you can go within convex. There are different kinds of problems, like semi-definite problems, cone problems, and so on. I just wanted to give an overview, a feel for what kind of functions can be modeled as an optimization problem and what that means for you in finding the solution. So the main takeaways I would say is, if you were to order with the difficulty to solve, linear optimization problem is the easiest to solve. Convex nonlinear is the next. Integer totally depends on the scale. Some of the smaller ones is pretty easy to solve, but if it's, let's say if you're trying to solve a knapsack problem with 1 million items, right, then it becomes really hard. Like the Kaggle competitions that happen every year around Christmas, the Santa problem, that's like that's a knapsack problem. And usually the gifts are around million or more. So these are really hard problems to solve. And then the non-convex nonlinear optimization, for example, a sine function, that is one of the hardest as well. So there are techniques, if you, for the first glance, you're looking at a problem and you come with an integer formulation or a non-convex nonlinear optimization formulation, there are techniques that you can use to convert them to their linear equivalent or convex equivalent. So if you can, I think trying to work towards making them linear or convex is always helpful. Just kind of giving an overview of different optimizers available. We saw Excel, but some industry, some other solvers that are commonly used in industry are Groby and IBM. Both of them probably have a Python way of accessing it and solving them. They're pretty reliable. Larger systems, like let's say if you are trying to optimize the revenue for an Adway, right? Like those guys use IBM or Groby for the problems that they work with. We have mostly been fine with using the open source solvers. Pulp is all of these are Python versions as well. I think NLP you can do either Python or R. I think these three are all Python based versions. Pulp is primarily for linear programming. These three guys, you can do both linear as well as non-linear. We have had some issues with some specific formulations with SciPy. When we try to validate the results from Excel with SciPy, we have ran into issues. So in the production, we are primarily using NLOpt. Couple of self-learning guides if you want to look more into optimization. Convex optimization by Stephen Boyd and Levin is kind of considered the canonical text. It's pretty theoretical. It probably can, in grad school, it's like covered in 2 semesters or so. But if you're looking for something that's more applied, I think model building and mathematical programming is a really good one. It has like 200 different problems that you can try to formulate. So with the optimizers that are available, both commercial and open source, I don't think if you're a data scientist or if you want to get into optimization modeling, you don't have to worry about how to solve the problem. What is more important is how you want to formulate the problem. So I think that is the more important skill to have if you are in the applied side. So that's just an overview of optimization landscape. Any questions?
Yeah, that's cool. Thanks for giving an overview of the different tools. Have you used, do you know of CVXPy?
No.
Like CVXOpt as a library?
CVXOpt, yes, yep. I think it's maintained by Stephen Boyd, if I remember right.
Okay. But I think there's another one, CVXPy. Are you familiar with that one at all?
No.
Okay. What's your preference when dealing with Python, like open source?
If it's linear, I'd go with Pulp. Pulp has been pretty reliable. If it's non-linear, NLOpt.
No, there's a package called Pyomo as well. Has anyone heard of that?
I heard it, yep. But I haven't found resources to good documentation for me to use it though. So I had some problem there. There is a website called coin-or. It has a list of different kind of packages in different languages and so on. So it's a really good resource if you're trying to hunt for a specific solver for your problem. Okay. So I think switching gears, going into how we are utilizing this at Extraspace. So the main thing that we want to do is, okay, over the past decade or so, there has been a lot of development. When I got in data science, random forests were all the rage. Now it's neural networks, right? So there's been a lot of development in getting better accuracies for regression problems and classification problems. And you with these developments, you definitely get better insights about the data that you're dealing with. But I think just insights are not enough. If you want to build an end-to-end decision system, what you want is, you want to see how you can use these insights to come up with decisions, right? So I think optimization models in that, they kind of solve the last mile problem within the machine learning landscape. So I'll go over a couple of examples on how we are using it. One of the bigger problems that we have is automating our PPC, which is pay-per-click account management. So we have multiple channels through which we acquire customers, right? Organic search listings, SEO, as well as paid search, Google ads, as well as social ads. We have a pretty significant dollar amount tied to our paid search campaigns. So as I said, we have 900 stores across the country, and we need to make sure that all of these campaigns are performing optimally. Not just at their geo level, but also across the whole portfolio. So the business ask here is, given this paid search account, can we maximize our total rental volume from our paid search campaigns while spending below a certain budget? We have a marketing budget that we need to meet, and managing this locally at each of these geos is a really hard problem. So to start solving this problem, we need to start with deriving insights from the data. So the data that is available to us are primarily these three data points. We have a city level click share and CPC data. So basically CPC is the cost that, CPC is the bid amount that you bid for your ads. So on the plot here on the left, I plotted that. So click share is in any given city for a certain bid, how much of the overall click volume can you capture? So for example, on the left here, for $5 in city one, you can go up to 20%. For $8, it's close to 40%. In a different city, it might be totally different. For the same $8, you can get only 30% because the competition might be pretty intense there. So we have this data around click share and CPC that we can get from Google AdWords and Bing. So with this data, we try to derive these sensitivity curves. Similar to CPC and click share, we have click share versus clicks. So what does a certain click share value mean at a city? So a 30% click share at a certain city can give me a little over 6 clicks. A 40% click share in city 2 would give me the same 6 clicks. So we have these curves that were generated from the historical data that we have that we got from AdWords. And on top of that, we have city level unit availability data. So if we want to optimize our spend, right? Like we want to spend in places where there is a lot of unit availability that we can rent and take money away from highly occupied cities. So then I can't go into the detail of the optimization model, but it's a very high level. This is what the optimization model does. maximizing the rental volume across geos. Spend across all the geos need to be less than the paid search budget. And there is by doing some testing, we have figured out that we can't really ever go to zero click share because it becomes, it affects our Google ranking, like quality score that is associated with our AdWords account. And similarly, we don't want to go ever be 100%. This varies by each city. We have these bounds that we have estimated to be the optimal bounds, and we've used that as parameters in our model. So the kind of final model pipeline looks like this. You derive these sensitivity curves for geo level CPC and click share and click curves. And then you have the geo level unit availability. It goes into the optimization model. And then we generate geo level paid search bids. So this is a high level overview of our paid search management system and how we use kind of regression, insights derived from regression models with an optimization model to solve a business problem. Questions?
Not seeing any on the chat. So yes.
Another example I would go over is on maximizing store revenue. So
I have a question actually. I'm sorry.
Go ahead.
So yeah, what's your experience? You know, actually, you get the results from a model like this, right? And obviously, the results are different than actually making a decision. So this, I mean, can you talk about the level of trust that you put in this and the level of indication that you get from optimization models in this use case, and how much does your management team, how do they utilize this, if you will?
So the bits that are generated from the system are what are uploaded back into AdWords. So they are live bits. The way we got there is, I would say, we do extensive testing. Like any new model that we want to try, we always test it out. So at the scale that we operate with 1,900 stores, with 1 million customers, right? So that gives us the scale to, I can do a property level or geo level test where I split the whole portfolio into two different, a test and a control group. Let's say the control is the AdWords, that's the one that's maintained organically by AdWords, and the test group is obviously this optimization model. And we have done these tests several times to show that this one has outperformed the base AdWords model. And that's how I'd say we earn the management trust in putting this model into production.
Got it. Thank you.
Cool. Okay. So now another example I want to go is the maximize store revenue. So we change our rates pretty dynamically as well. And let's say if there's a self-storage property, as the occupancy increases, you want to increase the rates. And if it decreases, you want to decrease the rate. So it's pretty logical common sense, right? So the problem is, how can we optimize new customer rate to maximize the overall store revenue? And again, going back to the data that we have and what we are looking at, what kind of insights we're trying to derive from there. So we have the seasonal demand forecast, and we have the seasonally adjusted property level price demand sensitivity curves and property level unit availability. So we try to forecast for a given year based on historical demand, what the demand we are anticipating, and then come up with these price and demand sensitivity curves based on historical data. And we also update these curves based on testing as well. We have been historically generating some rates, uploading it, getting customers, but sometimes we want to see, like, can we push the rates even higher than what the model is recommending? And we would try to push it up, and we test what that what impact it has on the demand sensitivities, and takes those learnings and incorporate that in the demand sensitivity curves. So talking through an example here. So let's say there's this facility with 100 units and 81% is the occupancy. So you have 19 vacant units, okay? You can come up with 3 different price points. And based on the demand sensitivity curve, we know what the demand would be at each of these price points. So at $146, we are expecting 12 of the 19 units to be filled, and that gives you a revenue of $1,752. At $121, you can go up to 17, and that gives a little over $2,000. If you were to go, you still have 2 units left, right? Like with the 17, you still have vacant 2 units. Let's say if you push it all the way to 99, then you can get as many as 22 rentals. But the problem is we are constrained by the vacancy that we have at our property. So 19 is the maximum we can rent, and the revenue is 1,800. So the optimization model, based on the data that we were just reviewed, would identify the 121 as the optimal dollar amount for the rate that we can charge at this facility. So again, an overview on the optimization pipeline. We have the property level price, demand sensitivity curves, seasonally adjusted, and then property level unit availability, and the optimization model taking into consideration the unit availability constraint generates the optimal pricing level at a property. So those are the 2 couple of bigger problems that we have implemented optimization and helped us optimize a process. Questions?
Yeah, I had a question. I had to deal with this similar kind of problem in a past life, dealing with recurring revenue. And I was wondering if your models take into account customer lifetime value as well as like month-to-month optimizations for customers who buy a service.
It doesn't explicitly. We have, on top of this, we have also, there is another modifier that we use in our optimization that kind of implicitly models it. So it effectively, yes, we are optimizing for LTV, but it's not explicitly modeled as a constraint.
Okay.
Yeah. Cool. So other widely used applications for optimization models, supply chain management. As I was telling, World War II, they were trying to optimize how do you place your ships so you can maximize the impact you can have on the enemy and those kinds of problems, right? So supply chain is a area where I would say the level of maturity they have around using these optimization models is very high. Inventory control, you want to make sure that you have the right amount of inventory at a production plant, so you don't create any bottlenecks, as well as you only have limited space to store, so you kind of optimize for those. Transportation scheduling, you can think about Grubhub, how they optimize routes when they want a driver to go around, pick up food and deliver it. So that's a transportation scheduling problem. Network design is like, let's say if Amazon decides to open a couple of warehouses, where does it want to place them so it can optimize for costs as well as reduce delivery times and so on. So these are some supply chain management has a lot of applications for optimization models. Other one is revenue management systems. We did an example. So, it started with the airline industry and it has now spread over to other industries as well. Staff scheduling systems. call centers, if they want to maintain a certain service level, how many call agents they want to work at any given point. You can model that as an optimization problem. Portfolio management, if you're like an investment manager, you want to maximize your profits, but with certain risk threshold. So model those as constraints. It's widely used there as well. Final couple of takeaways. The decisions are only as good as the data and assumptions going into the model building process. So we work really closely with our business partners in developing these models. Sometimes their assumptions get kind of questioned, or they see that some of their assumptions don't hold about the business when they go about this model building process, and they simulate based on the data available. So make sure that the data is reliable. At least you can make sense of what is happening, because your model is pretty logically defined, so it needs to meet those criteria that's defined in your formulation. As I was talking about our pricing tests that we do to always get a sense of what the price versus demand curves look like. So with these optimization models, they only look at the historical data to come up with the optimal solutions, right? It's not like a reinforcement learning problem where there is a part of the system that's always exploring, trying new things to learn. So I think that's one drawback, or I can say the last missing link in this kind of a setup, is that you need to actively test different scenarios, push your system to try operate at different scenarios and see what that returns. And then it goes back into your optimization model, and then that goes into the optimal solution.
I was going to ask, like how was it during, I guess, the springtime of this year with modeling pricing and demand because of COVID?
So what is the question, Joe? Sorry.
Yeah, I was asking, like, what was your experience trying to model pricing and demand during the early parts of COVID?
Both with the paid search system as well as this pricing system, we were doing a lot of mini tests where during COVID, we had to bring, like the beginning of the lockdown, we had to bring our rates down because we saw that demand was declining, right? So we were doing tests, kind of serial testing to identify what the right level is and go and try to operate at that. So kind of have a small portion of a portfolio kind of randomly always being tested on new spend levels as well as price levels to get an understanding of where the overall market is.
Thanks.
Cool. So that's pretty much what I have. Any other questions or comments?
From my observation, it's interesting. I think operations research is probably one of the more useful, I'm opinionating here, but one of the more useful areas of data science, but I don't really see it front and center like a lot of other techniques. Do you have any thoughts on that?
Yeah, I think it kind of depends on the education or the things that computer science departments and statistics departments, what they focus on. I think that's what we see in the job market is kind of reflective of that. It's like problems, some of these optimization problems are defined or are discussed in a computer science curriculum in an algorithms class. And so some of that has gone into how you go with model fitting for machine learning models, right? Like you try to optimize your parameters there. But I think the connection on how we can use those same optimization techniques to make business decision, I don't think that connection is being made in either the computer science or statistics. I don't think statistics departments teach them at all. So I think that link is not being emphasized. I think that's where the disconnect is.
I learned about a lot of this stuff in business school, so it's like,
Yeah.
oh, now I see it being applied to computer science. That's nice.
Yeah, I think the approach that I've seen in comp sci was more constraint satisfaction problems. Like I think Prolog is a really good example of like a whole programming language where you can just set up your constraints. I haven't played with them in a linear sense. The math I've used is more discrete, so more of the orcs and the hobbits, and it's a binary. Have they crossed the river? How do we make it so they can cross the river in X amount of turns? Yeah, this was really interesting, Adi. And then Joe will make sure to point you to our Slack. I pasted a bunch of resources while you were discussing this, especially the Python open source resources. Some direct like links to tutorials. So if anybody wants to play with this stuff later in Python, that's totally an option. So yeah, but this is excellent. This is like a whole branch of math that it's like some brain exercise. You were like our brain fitness trainer tonight on Zoom. So
Thanks, thank you. If there is interest, we can go into detail, take just one talk, have a talk around just linear optimization or convex optimization. Maybe we can do that sometime in the future if there is interest in the community.
Yeah, I kind of want to paste like a Jupyter notebook with maybe I'll do the orcs and hobbits. I haven't done that problem for 9 years, but I remember doing that one in comp sci, and it was.
I would make a vote for that, Adi. I think that this is one of the more useful areas, like I said, of mathematics and it's business analytics, if it's that. But like, I remember my first job, the boss asked me, so I need to figure out the best price for this product. And I was like, oh, let me get back to you real quick on that one. But these types of problems don't really go away in business, but I think in a lot of ways, like machine learning has sort of supplanted a lot of the interest and the demand. But like I said, this is like the bread and butter stuff, in my opinion. This is like all day. You could solve so many business problems with these techniques. It's insane.
Definitely, yeah. Like whenever people bring some kind of opportunity to us, we always try to see what is the decision that they're trying to make, and with the data that we have, can we solve that? That's the approach that we have taken here. Yeah.
So I have a question on the how do you when you have competition with other rental places, how do you take that into account into your model?
So traditionally, we have been the demand pattern, right? Like if we know that there is a saturation level of high saturation at a particular market, it's captured kind of in the price and demand curves, right? Like because there is only so many rentals you can get, and if you're competing with multiple stores, even if you reduce your price to 50% or 60%, you still won't be able to capture that big, right? So I think it's organically already captured in the demand curves. Does it make sense?
It does.
But if let's say if this is we were the market leaders or market leaders in a particular area, and then suddenly a new facility comes in, that kind of throws a little bit of a wrench, and we may have to change the data, how we look at that. So we need to account for sudden shocks to the system.
Because how much of your work is related to demand forecasting? Do you do that, or does somebody else?
We do that, like our team.
Okay.
Yep.
Cool. What's that process like?
So the thing is, there's a lot of the issue with our industry, I would say, is sparsity of data, because it's not like McDonald's where you get like hundreds of customers, right? Like you probably get 20 to 30 rentals a month. So we try to bucket them, aggregate them in a way that gives us enough reliability to forecast demand, but also keep some differentiation. if that makes sense. So we bucket our units and our properties together to come up with these yearly, monthly, half-yearly kind of demands, and we kind of look at all these different demand patterns, and each of them have some weightage, and we use that in our model.
So the storage industry is a weird one to forecast because it's for the consumer of the product. It's really difficult, or I would say it's not difficult, but it's painful to move your stuff, right? Like once you move into a storage building. For full disclosure, I own storage buildings, and so not like you guys, but we do have a small storage business, and it's people will just, it's crazy. We have somebody, I was out there a couple weeks ago, we have somebody who's been paying us money to leave their Audi car in our field for like the last 20 years. I don't understand why. They paid us like several times more than the car's worth, but sure. So it's really hard to forecast that because once you're in, you're kind of in. So it's only new entrants really that you're trying to forecast, at least in my experience. I don't know what you guys see. I don't know, like a totally different universe, but it's like McDonald's, like you point out, where people are coming and going and they have different options, right? Like lunch is lunch. So
yeah, we have some really long length of stay customers who have been with us forever. So they are definitely there. So yeah.
Thanks, Audie. Are there any other questions? Thanks again. Yeah, I'm looking forward to. I kind of want to explore this more, especially on the utility side. Like I feel like, I don't know. I know that kids are actually into a lot of these apps now, so I could even think of like one that's like, oh, put in all the stuff on your horse in Red Dead Redemption, and now you're not going to overweight the horse or something like that. And yeah, interesting. And I know that I keep talking about virtual problems, but yeah. Cool. Thanks for introducing us to that. So we're going to go ahead and do our raffle. Before we get too far in that, and as we're setting up for that, I will remind everybody that you have to be in the channel to win, and that channel is the meetup 1007 channel on Slack. So I will make a link to that. I think if you click on that link in the Zoom, you should be able to be in there. And the reason for that is what I'll be doing is just pasting everybody in that channel onto this Python program I wrote right here. So I just wrote something in VS Code. So we get to peer review together real quick. Port random, here's our Pythonistas. So I'll paste that in here when we're ready, and then print the winner. If you win, send me a Slack message with your address, and then we'll ship out a lovely raffle prize. So we're going to be giving out pretend this is the Halloween. It's actually a Pi badge. And we'll also be giving out a Circuit Python. So we're giving out 2 circuit boards along with some random swag, such as a mask and the gator. So let us, yeah, and you have to be in the channel. So see, Isla just joined us. Is everybody in who wants to be in? If you're like trying to make it through, just like react or say in the Zoom chat, hey, like I'm trying to get in the Slack.
I just joined. This is Ross.
Oh, hey, Ross. Cool. Okay. Yeah, and then Dylan's showing off because he's been coding on his.
Oh, I bet this will work, the colors now.
Nice.
Yeah.
Oh, nice.
We're not going to do it with the light strip, but this was the nice thing about the Halloween is it's got built-in memory, so you can use it just like as is. It's got a built-in screen, and it's got this port that you can plug, like buy an LED strip if you want. And so I ran some program that like slowly lights it up. We can control each of these individually, and then it manipulates it. And it works just by writing like a simple Python script that you throw on there. So you can go from software programmer to hardware programmer.
Literally by like copying a file. I love how easy it is. It's not that you have to hit compile or anything. It does it all on the board for you. So yeah. I was thrilled when I first saw that at PyCon in Portland, back when it was just the microbit. I mean, what a cool project. Awesome. Sweet. So if you don't see yourself in here, like, let me know right now, because you're literally not going to be a variable. No? I'm going to add Audie in here, even though he's not in the Slack, just in case. Let's see if you win here.
Thanks, Ferris.
Yeah. Thanks for the talk. It was excellent. Ready? Okay, going once. I usually just use this, but I don't know. I feel like trying out the IDE. I need to use the IDE more. So John Fackrell is our first winner.
Nice.
Awesome. Congrats.
Thanks.
And then, yeah, so send me your address if you haven't already in Slack, and that'll be my reminder to send you. Like, I actually have like USPS, like bubble wrap things ready to go, and yeah. And the next one is, oh no, did it just do it twice? You didn't win twice. Did I write this code wrong? No, here we go. You won twice, by the way, but I guess it's truly random. That's
With
funny.
replacement.
Derek Hansen, you are our other winner. Are you on the Zoom still? No? I almost want to say you must be present to win. We have enough that I'll do one more drawing. So if I can't get a hold of him, then it's fine. But if I can, we have enough for 3. So one more time. Drew. Hey, and Drew is on with his camera on. So congrats, Drew. Yeah.
Thanks.
Yeah, go ahead and send me your mailing address, and we'll get one of these shipped out to you ASAP. Hopefully before Halloween. Like the idea is, I kind of want to, you can put it on the door and say. I was thinking of putting an image of a mask and say, you got to have a mask if you're going to ring the bell. But anyway, thank you all for joining us again. Oh, this is my code. I was going to do this. I think I can do that, right? Isn't that the command? No. Well, the first Wednesday of November will be the 4th, so that'll be our next meetup group. Looking forward to seeing everybody there. Thanks again. I know it's been weird being remote. If anybody ever needs to just talk about hey, I need to talk Python stuff or just career stuff or needs any advice, feel free to reach out to me on Slack. And I will see everybody on the 4th. Thanks again. And have a lovely day. I'm going to keep this call going, but I will be ending the recording. So bye, YouTube.